So we are going through the method number 4, which is q of x is in the form of e power x into v of x. That x is an independent variable based on the independent variable. That v is either trigonometric, either polynomial. So if the v is either trigonometric or polynomial and that one is multiple of e power x, then we are going through the method number 4. In method number 4, what we will do? Yp is equal 1 by f of d into q, which is equal 1 by f of d into e power ax into v, which is equal, we are writing e power ax in front, we are replacing d as d plus a into v. So e power ax process particular solution completed. Now whatever function v is there, by using that function we are calculating the value of this one. So here on this basis we are doing a problem. So I am writing a problem. Solve d square plus 2 into y is equal e power x cos x. This is our problem. Now I am solving this problem. D square plus 2 into y is equal e power x into cos x. So he given in operator form. So directly write the auxiliary equation. Auxiliary equation is what? M square plus 2 is equal 0. So m square is equal minus 2. So m is equal plus or minus I root 2. So 2 roots existed, 2 roots are of the form, so which are nothing but 0 plus or minus I root 2, alpha plus or minus I into beta. So alpha value 0, beta value is root 2. So complementary solution is equal, for complex root solution is e power 0 into x, c1 cos beta value root 2 into x plus c2 into sin beta value root 2 into x. So complementary solution calculated. Now we are going through the particular solution. Particular solution formula, yp is equal 1 by f of d into q of x. 1 by f of d value is, what is f of d? D square plus 2. D square plus 2 into q value. What is the value of q? E power x into cos x. This is in the form of e power ax into v. So v is cos x, a value is 1. So write this e power x in front, replace d as d plus 1 into cos x, which is equal e power x into, expand this one, d square plus 2d plus 1 plus 2 into cos x, which is equal to e power x into 1 by d square plus 2d plus 1 plus 2 value 3 into cos x. So this exponential form completed, multiple, so only cos x remaining. So cos x means that is method number 2. In method number 2 we are replacing d square as minus a square, here a value 1, minus a square means minus 1 plus 2d plus 3. Don't change d, only d square, e power x into 2d plus 2 into cos x, which is equal to 2 common, take out that one common, 1 by d plus 1, rationalizing factor is d minus 1 by d minus 1 into cos x, e power x by 2, d minus 1 by d square minus 1 into cos x. D square value minus 1, so substitute that one. Denominator does not becomes 0, so minus 1 into cos x. Minus 1 minus 2, minus 2 into 2 minus 4, so minus e power x by 4 into d minus 1 into cos x. Multiply d inside, minus e power x by 4 into cos x derivative minus sin x minus cos x. Multiply minus inside, so e power x by 4 into sin x plus cos x. So I got particular solution. So here complementary solution, and this one is the particular solution. Write the general solution. What is general solution? Y is equal yc plus yp. Y is equal, yc value is e power 0 means 1. What is the remaining? C1 cos root 2 into x plus C2 sin root 2 into x plus particular solution e power x by 4 into sin x plus cos x. So this is called the general solution of the equation. Now in the same model we are going through the one more problem. So that problem is solve d cube minus 3d square plus 3d minus 1 into y is equal x square into e power x. X square into e power x. This problem we are solving. So here also right hand side is of the form. Here also right hand side is e power x into some function. What is that function? Function is x square. So solution given, he given this one is directly in operator form. Write the auxiliary equation. What is an auxiliary equation? M cube minus 3m square plus 3m minus 1 is equal 0. So this one can be written in the form of a minus b whole cube. M minus 1 whole cube is equal to 0. So m is equal 1 comma 1 comma 1. 3 roots are existed, corresponding complementary solution. 3 roots are real and equal, complementary solution c1 plus c2x plus c3x square into e power x. Now particular solution yp is equal 1 by f of d into q. 1 by f of d value is d cube minus 3d square plus 3d minus 1 into q value x square into e power x. Denominator can be written as d minus 1 whole cube into x square into e power x. So here e power x right in front, replace d as d plus 1. d plus 1 minus 1 whole cube into x square. E power x into plus 1 minus 1 getting cancelled, 1 by d cube into x square. So 3 times integration, 1 by d cube is nothing but 3 times integration of x square. So what is the first integration? X square, x cube by 3. So here e power x into 1 by d cube can be written as 1 by d square into 1 by d of x square, x cube by 3. E power x into 1 by d, again integration, x power 4 by 4 3s are 12. Again integration, e power x into x power 5 by 5 12s are 60. So yp is e power x into x power 5 by 60. So general solution y is equal yc plus yp. Y is equal yc. What is the value of yc? c1 plus c2x plus c3x square into e power x plus e power x into x power 5 by 60. So this is called the general solution of the equation. Like this we are solving all problems related to this. So here this is our model. What is this model? E power x into v model. Now here I am giving a problem, one more problem we are doing on this. Solve d square minus 5d plus 6 into y is equal e power x into sin x. In our end exams, he asked a number of times of this problem. Now we are doing this problem. So what is the problem? So he given directly operator form, write auxiliary equation. Auxiliary equation is m square minus 5m plus 6 is equal 0. So this one can be written as m square minus 2m minus 3m plus 6 is equal to 0. Take out common m minus 2 minus 3 take out common, m minus 2 is equal 0, which is nothing but m minus 2 into m minus 3 is equal to 0. So what are the roots? 2 comma 3. Two roots existed. Two roots are real and distinct roots. Corresponding solution is yc is equal c1 into e power 2x plus c2 into e power 3x. So complementary solution completed. Now coming to the particular solution, yp is equal 1 by f of d into q of x. 1 by f of d value. What is the value of f of d? This one. 1 by d square minus 5d plus 6 into q. What is the value of q? E power x into sin x. So x coefficient a value 1, replace d as d plus 1, write that e power x in front. E power x into 1 by d plus 1 whole square minus 5 into d plus 1 plus 6 into e power x into sin x. So already e power x completed. So this one will not exist into sin x. Sin x, which is equal to e power x into 1 by, now simplify this one, a plus b whole square, d square plus 2d plus 1 minus 5d minus 5 plus 6 into sin x. 6 plus 1 7, 7 minus 5 2, e power x into 1 by d square minus 3d plus 2 into sin x. A value 1, so replace d square as minus 1. So e power x into 1 by minus 1 minus 3d plus 2 into sin x. 2 minus 1, 1, e power x into 1 by 1 minus 3d into sin x. So what is the rationalizing factor of 1 minus 3d? 1 plus 3d. So e power x into 1 plus 3d by 1 minus 3d into 1 plus 3d, a plus b into a minus b, a square minus b square into sin x, which is equal e power x into d square value minus 1. So 1 plus 3d by 1 minus 9 into minus 1 into sin x, which is equal to e power x into 1 plus 9 e power x by 10 into 1 into sin x plus 3 into derivative of sin x cos x, 3 cos x. So I got complementary solution and particular solution, which is nothing but general solution formula is y is equal yc plus yp. If you are adding yc and yp, yc is what? This is yc, yp is this one. Add these two values, we will get the general solution of this equation. Welcome to the students. Now in this session we are learning another method number 5, and q of x is equal x into v. So here v is only if it is trigonometric, that means either sine or cos, then only you use this method. If it is an exponential, then go through the method number 4. Because of that method is very easy compared to this method. So here v is trigonometric, then only we are going through in this method. What we will do in this method? So here yp formula is 1 by f of d into x into v, which is equal here x minus 1 by f of d into f dash of d into 1 by f of d into v. This is the formula for the particular solution. What is that? 1 by f of d into x into v can be written as x minus 1 by f of d into f dash of d into 1 by f of d into v. So this is our formula. So we have to remember this formula carefully when the right hand side is in the form of x into v. Then only we will do the problem. So write an example. Solve d square plus 2d plus 1 into y is equal x cos x. X cos x. We are solving this problem. So first he given operator form. Auxiliary equation m square plus 2m plus 1 is equal to 0. This one can be written as m plus 1 whole square is equal to 0. That means m is equal minus 1 minus 1. Corresponding complementary solution. yc is equal c1 plus c2x into e power minus x. So because of that, two roots are real and equal. Coming to the particular solution, 1 by f of d into q. 1 by f of d, d square plus 2d plus 1 into q value x into cos x. So this is in the form of x into v. Formula x minus 1 by f of d means this one is our function f of d. 1 by f of d means d square plus 2d plus 1 into f dash of d. Derivative of this one, d square derivative 2d, 2d derivative 2, constant derivative 0 into 1 by f of d. F of d value d square plus 2d plus 1 into v value is cos x. So in this way we are solving this one, which is equal to x minus d square plus 2d plus 1 can be written as d plus 1 whole square. These two terms having common, to take out that one common, into 1 by d square. So which is in method 2. In method 2 what we are doing? We are replacing d square as minus a square. So minus 1 plus 2d plus 1 into cos x plus 1 minus 1 getting cancelled into x minus d plus 1 getting cancelled, 2 by d plus 1 into 1 by 2d into cos x, which is equal to, write this 1 by 2 outside, x minus 2 by d plus 1 into 1 by d. 1 by d stands for integration. Integral of cos x is minus sin x, which is equal to 1 by 2 into, multiply minus sin x inside, minus x sin x minus into minus plus 2 by t plus 1 into sin x, which is equal to 1 by 2 into minus x sin x plus 2 into rationalizing factor d minus 1 by d plus 1 into d minus 1 into sin x, which is equal 1 by 2 minus x sin x plus 2 into d minus 1 by d square minus 1. Because of that, denominator is d plus 1, d does not eliminated, and that's why I rationalized that one with d minus 1. So denominator is d square minus 1. 1 by 2 into minus x sin x plus 2 into d minus 1 by d square, as minus a square means minus 1. Minus 1 minus 1 minus 2 becomes 1 by 2 minus x sin x plus 2 into derivative of sin x cos x minus sin x by minus 2. 2 getting cancelled. So both terms having common minus, take out that one common, x sin x plus cos x minus sin x. So this is the particular solution of the problem. Now general solution is, y is equal yc plus yp. Y is equal yc. What is the value of yc? This is the value of yc. c1 plus c2x into e power x plus into minus. So this is minus 1 by 2 into x sin x plus cos x minus sin x. This is the particular solution of the problem. Like this, we are solving the solution. We are solving the problems which are in the form of x into a. Now we are going through one more problem, which is which one we done. Which one is very important one. So here variables are changed. Solve d square plus 1 into x is equal t cos t, comma x is equal dx by dt is equal to 0 when t is equal to 0. Here this is very important problem. This problem having initial conditions. That means we have to calculate the particular solution related to this problem. So first calculate the complementary solution. Before going through the problem, here you have to observe what is the independent variable, what is the dependent variable. Here observe this, x is the dependent variable, t is the independent variable. Corresponding to this, we have to write the solution. So here first auxiliary equation is m square plus 1 is equal to 0. That is nothing but m square is equal to minus 1. That is implies m is equal plus or minus I. That is nothing but m is equal 0 plus or minus I into 1. They are in the form of alpha plus or minus I beta. So generally y dependent variable, x independent variable means complementary solution yc. But here x is the dependent variable. So complementary solution is xc is equal independent variable t. Remember that. So e power 0 into t, because of that alpha value 0. c1 cos beta t 1 value plus c2 sin beta t beta value 1 value. So xc is equal e power 0 value 1 c1 cos t plus c2 sin t. This is related to the complementary solution. So here I calculated the complementary solution. Now I will calculate the particular solution. So xp is equal, formula is what? 1 by f of d into q of x. 1 by f of d. What is the value of f of d? D square plus 1. So d square plus 1 into, here not x, t, q of t. T value, right hand side value is t cos t, which is equal to, which is in the form of x into v, t into v. Formula for this, t minus 1 by f of d into f dash means 2d into 1 by f of d means d square plus 1 into cos t. Simplify this one, t minus 2d by, so write this one as it is, don't change, 1 by d square plus 1 into 2d. Now simplify here, which is method 2. In method 2, what is the form? D square replacing as minus a square. Minus a square means minus 1. Minus 1 plus 1 becomes as 0. If it is 0, what we will do? We are writing independent variable in front. After that, we are writing denominator as derivative. D square derivative is 2D. Constant derivative 0. So cos t, which is equal to t minus 1 by d square plus 1 into 2d into t by 2. 1 by d. 1 by d stands for integration. Integration of cos is minus sin t, which is equal to multiply inside. So t into t square by 2 minus t square by 2 sin t, minus into minus plus 2 getting cancelled, 1 by d square plus 1 into d of t sin t. So that means applying derivative for t and sin t, which is equal to minus t square by 2 sin t plus 1 by d square plus 1 into derivative of t sin t, uv formula. What is uv formula? T into sin t derivative cos t plus sin t into t derivative 1, which is equal to minus t square by 2 sin t plus multiply 1 by d square plus 1 inside, 1 by d square plus 1 into t cos t plus 1 by d square plus 1 into sin t. So this here 1 by d means tans, 1 by d means integration. Integration of cos is what? Sin. So this is plus. So this becomes plus and this becomes minus. So this is minus. This is minus. So which is equal to, so this is plus. So don't write minus here. Which is equal to t square sin t by 2 minus, see this one, 1 by d square plus 1 t cos t. See this 1 by d square plus 1 t cos t value is xp. Instead of that, write xp plus, now d square as minus a square. Minus a square means minus 1. Denominator becomes 0. Write t in front, t into 1 by 2d into sin t. Bring this minus xp into the left hand side. Minus xp comes to the left hand side plus xp. xp plus xp is equal t square sin t by 2 plus t by 2 into sin integration is minus cos. xp plus xp value is 2xp is equal t square sin t by 2 plus into minus, minus t cos t by 2. So 2xp value is this one. From this, what is the value of xp? xp is equal to common. So 1 by 4 into t square sin t minus t cos t. This is called particular solution. Now we will go through the general solution. After that, we are applying the initial conditions. What are the initial conditions? X is equal to dx by dt is equal to 0 when t is equal to 0. Here see this, here I multiplied minus for this. So if I multiplied this one also, I will get minus. So this is also minus. So integration is minus, minus into minus plus. So this one is plus. So this is plus. So xp value is 1 by 4 into t square sin t plus t cos t. Now we are writing the general solution. So what is the general solution formula? X is equal xc plus xp. X is equal xc. What is the value of xc? c1 cos t plus c2 sin t plus xp value 1 by 4 into t square sin t plus cos t Let it be equation number 1. Why equation number 1? Here he given two conditions. X dx by dt value is 0 when t is equal to 0. So here I am differentiating this one with respect to t. X derivative is dx by dt is equal c1 into cos derivative minus sin t plus c2 into sin derivative cos t plus 1 by 4 into t square into sin derivative cos t, uv formula, u into derivative plus sin t into t square derivative 2t, cos t derivative is cos derivative minus sin t. Let it be equation number 2. What is the first condition? When x is equal to 0, dx by t, when t is equal to 0, x value is 0. So, if t is equal to 0, x is equal to 0. This is our first condition. So, by using that condition, substitute those values in equation number 1. So, t value 0, x value 0. So, 0 is equal t value 0, cos 0, 1, c1, sin 0, 0, 0 into anything 0, cos 0, 1, 1 into 1 by 4 plus 1 by 4. So, c1 is equal minus 1 by 4. Now, I will calculate c1 is equal minus 1 by 4. What is the second condition? At t is equal to 0, dx by dt is equal 0. Use this condition in equation number 2. 2 implies, substitute t0, dx by dt 0 in equation 2. 0 is equal sin 0, 0, cos 0, 1, c2. T value 0, so this value 0 plus 1 by 4 into this one 0, this one 0, this one 0. So all values I got as 0. That implies C2 is equal 0. So I got C1 as C1, so this sin 0, 0, cos 0, 1, C1, C2 plus 1 by 4 into t value 0. Next, sin t into t square value 2t, cos derivative is minus sin t. So total value 0. So C2 is equal 0. I got this value as 0. Yes. Here, here what is this value? T into cos t. So this one is cos t into t. Then this one changes as cos derivative minus sin t into t plus t cos t into t derivative 1. This is our equation number 2. And that's why here this 0, 0, 0, this one cos 0, 1. So this is 1. So this one is C2 is equal minus 1 by 4. C2 also I got as minus 1 by 4. So C1 is minus 1 by 4. C2 is minus 1 by 4. So substitute those values in our equation number 1. Therefore, 1 implies x is equal C1 value minus 1 by 4 minus 1 by 4 cos t. C2 value minus 1 by 4 sin t. So plus 1 by 4 into t square sin t plus t cos t. So this is called the particular solution of this problem, and this is very important problem.